Okay, I just want to talk about the marine sextant. First of all, just talk about how we lift the sextant out of the box. I've already got the sextant out of the box, but when you do lift it out, you must lift it by the main frame. Don't lift it out by the shades or the mirrors or the telescope or the index arm. Lift it by the main frame, and you must lift it with your left hand. So you lift it out of the box with your left hand and you place the sextant in your right hand. So once you've lifted it out gently with your left hand, you then place it straight into your right hand, and it is held firmly in the right hand. So let's look at the sextant now. And at the bottom here we have, as you can see here, the scale, and that goes from -5 degrees right through on this particular sextant up to 125 degrees. So the main arm there, the scale, shows you degrees, and we can see here 20 degrees, 21, 2, 3, 4, 25 degrees through to 30, 35, 40, etc. Then just here, I'm pointing with the pen, this is the micrometer or the micrometer, and you can turn this round to adjust, and this gives you the reading between degrees. So for example, you may have the sextant set on approximately 29 degrees. Well, it's between 29 and 30 degrees, and to find out the value between 29 and 30, you look at the micrometer here, and that gives you the reading in minutes and seconds between the degrees. So that's the scale or the reading, and that will be the altitude that you'll be reading off. This particular item here that I'm moving is called the index arm. Now it's on a clamp, and as you squeeze together your thumb and your forefinger at the end, that will release the arm and enable you to smoothly move it up and down the scale. Then when you let go of it, it holds it in place. And connected to the index arm is what's called the index mirror, and that's this object here at the top. So that's the index mirror here, and as you see, as I move the index arm, as I move that, you can see the mirror itself changing direction. So that's the index mirror. So the index mirror is directly connected to the index arm, and that moves when you move the index arm. Next to the index mirror are the shades that you would use if you were observing the sun, for example, and there's 4 different shades, and you can use different ones depending on how bright the sun is. So that's the index mirror. On the back of the index mirror is a little screw that you would use. We have a small screwdriver with the instrument, and that goes through. There's a little hole on the back of the screw there, and you can position this into there, and you can twist it one way or the other to make adjustments. And on the back of the second mirror, which is the horizon mirror, there are 2 similar screws, again, which you can place your screwdriver in to make adjustments, which we'll come to later. So that's the index mirror with the shades. Then you come to the horizon mirror, and the horizon mirror also has shades as well. So both mirrors come with shades to use with sunlight. Now, the horizon mirror is fixed. That doesn't move. The important thing to notice about the horizon mirror is that it has 2 parts to it. It has clear glass on the left hand side, and then it has reflective glass on the right hand side. So you've got clear glass and reflective glass. That's a very important point to consider. So let's first of all think about the principle of the sextant itself. Well, the principle really is that the celestial object that you're looking at, when you actually pick one up and it's reflected through your index mirror, the object is actually reflected twice in the same plane. That is, this celestial object is reflected through your index mirror initially. So when your index mirror is pointed towards the sky, the object is reflected through that mirror. It then goes through the horizon mirror, then through the telescope to your eye. So the celestial object is reflected through the index and the horizon mirrors. It's reflected twice in the same plane. Now, twice the angle between the mirrors must equal the angle between the first and last reflection of the celestial object. So that is, when you get twice the reflection, the angle between, it must equal the angle between the first and last reflection of the celestial object. In other words, when you read off your scale at the bottom, that must be the altitude that you're reading, because it's twice that it is reflected. So let's have a look how it works. We set our index arm to 0, and if we then looked at the horizon with the index arm at 0 and we had no errors, we would see through our clear glass here, our horizon mirror, the horizon on the left, and we would also see the horizon in the same line through the reflected mirror, because the horizon will be reflected through our index mirror, through our horizon mirror, through the telescope to us. So we'd see them in line. If you then point your telescope up and look up into the sky, for example at the sun, and then you pick the sun up in your telescope, you would then turn your index arm, and as you're turning it, your sextant is moving towards the horizon. So initially we've got the sextant pointed up into the air, and as we've released our index arm, we bring the sextant, if you like, down to the horizon. What we're doing there, we're getting the reflection of the celestial object through our index mirror, through the horizon mirror, through our telescope into our eye, and we're, if you like, bringing it down from up in the atmosphere down to the horizon. And when we've got it almost on the horizon, we then adjust with our micrometer, to get it so that it's exactly in line with the horizon. So what you've in effect done, you've brought that celestial body down from the sky to the horizon that you see in front of you at sea. And the reading on your index arm is the altitude of that celestial body. So between yourself and that celestial body, that is the altitude or the reading that you have obtained. And that's how you get the reading with your sextant. That's the basic explanation, that you set your index arm at 0, look up into the sky until you see the star, the sun or the moon, whichever, and bring that down by releasing the index arm and moving the sextant towards the horizon. Then when you've got the exact amount, you can then read it off your sextant. And of course, equally as important, the moment you take that reading, of course you have to get the exact time that you take the reading in order to calculate for your sight.